Okay, starting with number 21 from the homework. So unfortunately I didn't have the file pulled up, so we'll just have to sketch a little bit. All right, so we've got our 8 root 3 right here. We've got third of these problems is that we can be given just one side. And if there's special triangles, special right triangles, then it's the key to all the other sides in the picture, which is so nice. Okay, so what do we have? And what is it across from? We know that 30 has to go here based off of those angle measures right there. So we have the side across from 30, 8 root 3. So we're going to follow our table. So take x and multiply it by root 3. Take x and multiply it by root 3. Some people like to write this step. I usually skip that one. Beautiful whole number 24. This step says take, well, do we need that one? Yeah, we need that one. Take x and double it. Take x and double it. So take whatever x is and double it. Notice I did not touch the radicand. I did not touch the number underneath the radical. Okay, so 16 root 3. We need to place it back on our picture in the right spot. Yeah. Okay, we're back. Okay, cool. 16 root 3. Oh my goodness, what do I have and what is it across from? This is great news, people. The root 3 is across from 60 for once in our life. Woohoo! So I'm not even going to draw the table. Since the 16 root 3 is across from 60, the 16 goes across from 30, and we double it to get across from 90. The short leg and the hypotenuse are always half and double, double and half. Number 28. Which triangle should we work with first? We need perimeter. So we need everything, right? Okay, we want to work with the easiest one first. That's awesome. What do we have and what is it across from? Oh, 10 is across from 45. So we can simply apply our rule. X, x, x root 2. Got it, Asha, thank you. X, x, x root 2. Beautiful. Okay, now unfortunately, in the other one, 10 is across from 50. In the other triangle, 10 is across from 60. So if we're not used to these yet, then we make our little table, 30, 60, 90. So 10 goes here. We know we have to undo what's being done to x. Right now, x is being multiplied by root 3. So we do the opposite of multiplying by root 3, and we divide by root 3. It is improper to have a radical in the denominator. We've got 10 root 3 over 3. Oh my goodness, it doesn't get much uglier than that. So that goes across from our 30. Phew. Okay, and then across from 90, we need to go from here to here. All you do is just double this thing. Now, treat this like a fraction. 10 root 3 over 3. I'm going to double it. But just think of if this was 10 thirds, and I told you to double it, that's like multiplying it like this. The only thing you're going to touch is the 10. Do you see that? You don't double the 10 and the 3. That's not how you double a fraction. Okay? So even though I'm doubling this, the only thing I'm going to touch is the 10. Okay. 20 root 3 over 3. 20 root 3 over 3. Now we have the job of adding the sides. Find all the integers and add them up. Does 10 count? One of them does, right? But don't count the altitude. So this one counts as one of my integers. That's the only one I see. Now let's find all the root 2's. All right, that's the only one I see. Now let's find all the root 3's. And thankfully they are over 3. They're both over 3. They are like terms with a common denominator. These are like terms with a common denominator. Look how pretty. Are you waiting? Are you waiting? 30 root 3 over 3. Whoa! That's how that 10 root 3 got there. The answer seems so work to get there. It is beautiful. All right, 25. Doesn't look like it belongs in this unit, right? That looks like that belongs in a unit not called right triangles, correct? That is not a right triangle. Asking to find the perimeter. Ooh. I will give you a secret. Are you ready? This will work for every problem that's not a right triangle. It'll work for the trapezoid. It'll work for the isosceles trapezoids, the non-isosceles trapezoids, and the triangles that are not right. Every time you draw an altitude. Every time. So if you have a picture like this, and you're trying to solve it, what do? You go to a vertex and you drop an altitude. If you have a picture like this, and you don't know what to do, and you're trying to solve it, what do? You go to a vertex and you drop an altitude. Same thing here. I don't know what to do. I go to a vertex and I drop an altitude. I'm saying drop because you draw it to the opposite side, and it makes a 90-degree angle with the opposite side. Notice, did I split up 120 into 90? No, I drew 90, drop an altitude to the opposite side. So if on the test, if you need to turn your paper and you'd rather it be facing you so the altitude is going up and down, you can do that. What did we create here? Well, this is 30, this is 90, oh my goodness, so this is 60. That means I just bisected that angle even though I didn't know. I wasn't bisecting it on purpose. So this is 60, this is 30. So that's an altitude. It's also an angle bisector. Okay, now we can totally solve this problem. That was the hard part. I'm going to do the rest of it very quickly. 10 is across from 90. So we've got 5 root 3. This is symmetrical because we bisected the angle. So 10, 5 root 3. Perimeter time. Add up all the integers. 10 and 10, 20. Add up all of the root 3s. 5 plus 5, 10 root